Okay, great, thanks.
Awesome. So yeah, I guess I'll go through just pulling the repo and going through, and then if there was a part that you were stuck on, Heather, feel free, interrupt, chime in.
Okay.
So I'll just go through the description of the repo, try to get the example set up, and then try to generate the ZK proof from the result. Is everyone familiar with the maybe like a live example for it? Maybe the first thing that I'll start is, what can this be used for? Maybe, or is everyone still familiar with it, or should I just deep dive without any background? I want to potentially show you like a live implementation for just how it might work.
I think that could be helpful, and then as long as then maybe show us how it works first, and then show the live implementation, I think might be the.
Got it. Okay, so just share the code first. Okay.
Yeah.
So
because for like I've been trying to get it running, and then like I said, I've had problems with some steps of it.
Perfect. Okay. So in that case, I will I'll just create a new. Let's see if I have anything that's here. Just want to make sure that the documents that I have are not. Just when I share my screen, I want to make sure that I'm not sharing sensitive content, but everything should be fine in that way. Let me just share my screen. Here. Okay. All right. Does everyone see my screen?
No. Oh, now I do.
Oh, perfect. Okay. All right. So where we're going to be going to first. So we have docs.zkm.io. And then in the docs, we have the ZKM project template. Now, the project template itself has it's pretty descriptive in terms of the README. So if you are using the template, which I highly recommend, going out, like using the template and reading the READMEs directly will be more helpful than the documentation. So I'll just say that this should all information that you would need would be present in this project template. So the first thing that we would do is we would clone the project template. So I'll just go to my terminal and then documents code, and then I will do mkdir. Let's do demo. Sorry if this is a bit too small. Let me see.
Yeah, could you maybe? Yeah, good. Thanks. Yeah.
So cd. Oh, I'm in the demo, and I'm cloning the repo. I think you might. Oh no, never mind. It's HTTPS. Never mind. So you won't get an error if you're just pulling directly from that. So now we have the template, and then we will cursor. Now we have the template right here. Let's see if I can also scale this. We have a few folders here. The main folders that you'll be working on will be the guest program and the host program. But just to go through the documentation, the setup instructions, if I can find my browser right here. So the first part of this is anyone here using a MacBook?
I am, but I was running it in the Docker file. So I actually had to modify the Docker file to get some things running, but I used the Docker image, and then I was doing stuff in the Docker image because it was Linux.
Perfect. Okay. So we just recently added in that Docker file. I think it's just a few days ago I added it in. But there is a Docker file inside the repo.
Is that the way you suggest to do it if you're not on a Linux machine? Is to do it inside the Docker container?
Correct.
Okay.
Now, there is setup instructions inside the Docker file. So we will likely have this part of the documentation, but for now, inside the Docker file, what you would do is you would take this. Let me just see if I can get the console or the terminal to show up. So you would essentially paste the commands docker build. Docker is not run. Docker needs to run. Okay. Okay. Engine running. Okay. So essentially, one of the when compiling Rust-based code into MIPS, there is, I believe, a missing library for specifically like the Mac component. If you do this on Linux, you don't need to do this. And if you run or you prove Golang based programs, you also don't need to do this. This specific process is just for the creation of MIPS based binaries for Rust based programs. So for example, mem alloc-vec is a main.rs. So this is a Rust based binary. SHA-2Go is a Golang based. So you don't need to do this for Golang, but this is essentially creating just a Linux environment so that you can utilize or like build these programs directly on your MacBook. So once that's there, still have to pull a bit of this. As we wait, I think I'll just, oh, there we go. So then we would go into here, and now we are in the Docker container, which contains the ZKM folder. Now it doesn't contain the ZKM project template folder. This is, again, like we're working to make this a bit more of a seamless experience, but for now, cd home. If you're running this within here, I have to clone the clone the repo again. Unfortunately,
I found a command that I use for Docker so that it would mount that, and I could actually, so that the whole project template was actually inside the ZKM directory in the container.
So it's within there. I think with the volumes, yeah.
Yeah, it was just a slightly different I added something to the Docker run command, and then it does that.
Got it. So,
but if that command isn't doing it, then yeah, you'd have to clone it inside the.
Yeah. So just for simplicity, but like the development flow for Mac development will change, but for now, just the cloning it within the repo would be sufficient. And then now we have we would operate within this essentially environment. Sorry, off the tip of my tongue. Unfortunately, within this environment, to connect to it, we can go into, there's a Docker extension that you can use, and then you can essentially go in and observe the files and then operate directly off of it. But it does add a little bit complexity to this. If this is, a demo, I want to make sure that it's clear for everyone. So I'll just build for now, I will just build the Golang based programs, but everything that you can do, you can run the commands inside here to build the Rust based programs. And then essentially just a simpler flow, because I want to make sure that everyone sees the individual files and just what the process is for setting up the programs. But if you're building Rust-based programs, you would have to do it, and especially on a Mac device, you would have to do this Docker command step. But for now, I want to just go over the example of building the Golang-based program, and then from there, we can Rust would work in a very similar way. So I'll just exit here. So after we had this, after we set this up, we would need to go in and compile and essentially get a library, the MIPS Rust tool. Now for this is Rust-based programs. You would run this inside the Docker container for Rust.
Yeah.
But for Go already has MIPS built into their build, so you don't need to do this for Go. So we'll just go with the second option. We don't need to install Rust because Rust has the issues that I mentioned for Mac. So in this case, we will cd into the guest program, and then we go into cd sha2.go. And from here,
just to be clear, Pavel, so right now you're actually on your Mac, or are you in the Linux container right now?
I'm on the Mac.
Okay, so you're running the Go stuff on your Mac. Okay.
Exactly, yeah. Go runs on Mac, but the Rust compilation doesn't, yeah.
Okay.
So
all
right. In this case, we will build the actual main.go, and this file essentially is what it's doing is it's reading the input data provided by the host, and then in the guest it is running a comparison check if it is if the hash of, if you know a certain value of a specific hash. So this is basically what it's checking. If you do, it would then commit data to the actual proof, and then exit from there. If it doesn't, then it will throw an error and will not generate a proof. But what we did just with this command is we have created a MIPS binary or an ELF binary for the MIPS instruction set. So this can be run within the zkVM. So now that we have this, go down the so to step 2, building the host program. So first is we want to compile a snark library. So host program cd, or actually we can just do that within here. So we take this as a snark library, and it will be, I think, part of the SDK. Now, again, there is like a brief bug. So when we're actually building this, you'll encounter it, but I'll show you how to fix. But that'll be like a little bit later. But the first step is to take the the libsnark library and bring it to your computer, and then you would build the main program for that for the ZKM prover. So this is essentially building this program within the host program. The concept behind the guest program and the host program. So if I were to describe what this is, actually, let me see if I can visually go into Drive and go into deep dive. There is a good diagram that I want to show just so that people are aware how it looks like. So the actual, think of the guest program as the program that you are running within the zkVM. The host program is the external data that you are putting into the program that you are running on in the zkVM. So it's essentially just how you structure the data that would go into the guest program. So for example, over here, there is different types of programs here that are set. So SHA-2 Rust, SHA-2 Go. If we take a look at the set SHA-2 Go input. So for example, if we go over here, this structures the input data so that the program itself would be able to know how to use it. So for example, there's the command read data. And so what we're doing with the host program is we are reading the data that we are putting into the program. And in this case, we have a data object here, I believe. So it's like a struct somewhere here. Yeah, right here. So over here we have this struct and then this is, I believe, specific to Golang based programs. And then we also have, a deserialized version. So we have this struct data object that we're passing in, and depending on the corresponding data type that you want to use, you would put that in as part of the input. So does that make sense?
Yeah, so this is creating the input that you're going to then feed into the circuit, which is the guest program. Is that correct?
Yes. Yeah. Okay. You are within the host program. You are structuring the input that you are sending to the guest program. So there's a couple examples of how, for a Golang based program, how that looks like, and then for a Rust based program, I think with up. So in here, SHA-2 Rust input. And it's a bit different over here. So essentially the inputs that we would put in wouldn't be part of the data object. This is done differently. We have like the public input stream, private input stream. So we, in this case, pass the data directly to the program without structuring it into the data object that Golang would require. Okay, so yeah.
Yeah, sorry to interrupt. Hey, Pavel. Is this similar to the witness generation step in terms of like if you were to compare it with the Grot16? Like, is this the equivalent of witness generation?
So witness generation for Grot16. So what we are doing here, and I believe just in terms of witness, I'm assuming that you mean like the actual like inputs to the program.
Yeah, the private inputs.
Yeah. So we are essentially structuring the inputs that are going into the program, the witnesses that are going into the program, and then from here, we are using the inputs, and then also taking the inputs of the program and then also structuring the outputs from it. So to answer the question is, you are creating this environment where you are taking the inputs and the outputs of the program. You are structuring the inputs that you are sending to the guest program, and you are also formatting the outputs that are produced by the execution of the guest program.
So the host program is also formatting outputs?
So it is receiving the outputs. So in the case for SHA-2 Go, I believe that the execution of it, there's the execution here. Yeah. So the output stream is empty. So it would essentially get the return data from here. So as part of the data object. So if you see right here, we deserialize the data that is produced from the program, and I'll show you how that looks like within the execution. Does that make sense? Yeah.
Yeah. So like the host program would change based on the guest program. Like if the guest programs has like a certain set of inputs, the host program will also have to condition those inputs and outputs, and that's how it would change based on the guest program. Is that right?
Correct. Yeah. So it's essentially what data are you trying to put into this guest program,
Okay.
and how will you use that data after it is produced by the guest.
Okay. So right now the host program just has those template guest program. It has the templates for the guest program. It does not have. It would not be generalized, right, to any guest program. It's not
Yeah.
general.
Yeah. So you would need to fill in the specific inputs, for example, that would be required by the guest program. So like, for example, in the SHA-2 implementation, if I go back to this guy, so if I set the inputs, I am creating a data object. I am putting in the specific data object the inputs, so input 10, input 12, and then from there I pass the data object to the public input stream. So right here, or sorry, to the serialize into, yeah. So I put it as part of the buffer. So right here, sorry. So I take the data object, put it into a buffer, or create a buffer, serialize the information so that it can pass to the program, and then I would be able to deserialize it within the program. So in this case, like based on this data type, I would then be able to read the data and then select certain parts of it.
Yeah. Okay. So do you suggest like extending this code for our guest program, or like creating a new copy of it?
Yeah. So if you were going to use Golang, for example, you would need to change, depending on the program that you're putting, but likely you would need to change the data that you're inputting to the program. But like the core of it, so that this data object is provided, I would say, as an example, but I think you can change aspects of this data program. So you don't need to pass in like exactly this type of data type. You can put it in with any information. So like, for example, input 2 could be string. So it doesn't need to be that specific data type. It's just, this is used as more of like an example that you are on like what data types would be accepted as part of this operation. Does that make sense?
Okay.
Yeah. You want to make sure that the data that you are pushing in, though, so the data object that you're pushing in is matching the data object that is in the that you're reading from the guest program. So if you do change, so let's say you do change the data object on the host program, you have to make that change to the guest program as well, if that makes sense.
Yeah.
Okay.
Yeah.
Cool. Okay. So from here, so we're going through the steps of, we just built our zkm-prove.rs file. And so over here, we are taking the public input stream and we are putting it into the program over here. So this is essentially what is being put into the program for execution. Now, likely you will be testing this over the course of many iterations, and you want to make sure that whatever you're putting into the program, whatever you're getting out to the program, is presentable in, I guess, like for debugging purposes, and you don't want to execute the program. So you have you have a script over here. There's run local proving and run network proving. So local proving over here, we have this execute only to false. So this would generate the proof. And of course, it would take a bit of time. In this example, I want to basically run through how this would look like using this execute only to true. You would essentially be able to see the output of the program directly into the console. So right now, I'm basically just setting the execute only to true. And from here, you have additional information. So this is SHA-2 Rust, and I believe the SHA-2 Go would operate in the same way. So if I were to structure this command, so I would go into cd host program, and then as part of the host program, I have run local proving.sh. Run local proving.sh, and then I would run SHA-2 Go. So from here, I have compiled the guest program. I've taken the binary, and it's I encounter an error. So I mentioned this error happened with this. The main reason for this is because it's the actual compilation of the program doesn't add in the library to the file that it's requesting. So you just drag and drop it in to the host program. So it basically just saying like, hey, we don't have the actual library libsnark to operate off of. So you would essentially take the libsnark file that you have gotten from the previous step, which is right here. If you compile the libsnark, you would take it from the SDK src local libsnark, and then you would drag it to the host program, and then it should sit right there. We will fix this in the future. This is just something that needs to get done. But you can run this again, and it shouldn't, and you shouldn't get the error anymore. So if I go over here,
sorry, can you just so that libsnark thing that was built in the previous step, we have to copy that into the host program SHA-2 Go directory, or just the host program main directory?
Just the host program directory. Yeah, you would just take this library and put it into the host program. So from there, we just got our proof back, and we can see return data, the data object, the different inputs to the data object for that, and we see that input 10 is the SHA hash that we have submitted, and input 12 is the value of the SHA hash, and we see that this guest program executed successfully, which means that no errors were encountered, and we have successfully committed the data from that proof. So just for clarity, let's say the inputs are changing. So in terms of our args right here. So let's say because this program, the guest program or the Golang program, is comparing the hash of the program to the actual value corresponding to the hash. You want to prove that you know a specific value as part of the program. So let's say I remove the exclamation mark from world from this. So in this case, the hash would be completely different. But let's say I leave it as is. So in this case, it's an invalid, like the value does not correspond to the hash. That's basically what I'm changing for the program. I'm going to run this again. And then right here, we see that there is an error right here. So this X does not equal to X. So in this case, the program execution failed. It threw an error. of course, you know, we'll probably display this information in a better way rather than the null date, I guess. This is the POSIX date of when history started. But yeah, essentially output stream is too short. So, but the program ended up failing because the value of the proof or value of the program input did not match the hash of the input. So that's what the program is checking. So yeah, that's the essence on how to use it. I'm assuming everyone here might have a machine that has 16 gigs of RAM. If you don't, then there is the network proving. But actually, network proving is better to use just in general because it's basically like a beefy machine, 256 gigabytes. So it reduces the proving time. Now, let me actually run the proof generation false and see how that works. So I have the world, I have the hash. So I'm going to run this without the development environment. So I'm going to actually generate a proof from this here. And so, one thing actually, forgot.
Yeah, I kept getting that error. Yeah.
So in the seg size, now this is where the docs come into play. There is a proof generation guide. Depending on how much RAM your system has, also relates to the seg size that you should use. So this MacBook has currently 18 gigabytes of RAM. So the lowest possible value that I can choose, or the highest possible value, is this 32768. So this is essentially the value that you need to put in for the seg size. Because the seg size is too big, you would have to reduce it. Now, if we run, it should what's it called? Generate the proof from this. So hold on.
But if we see that, that means that's not working, right? Because I was getting that at segment number 15 because I tried the local, and I have 32 gig of RAM. So
okay.
Stephen had put like a number in Discord, and I tried that, and it errored out on segment 2, and then I halved it, and it still errored out on segment 2. So I haven't yet been able to do a proof locally.
I believe this it will continue. Just yeah, my fans are working, so I think this might not be an error potentially, but let's see. It should.
So how
work.
do we know? How do we know if it's working?
If you would know if there is additional like something is entered here. Let's see. Yeah, there it is. So it's not an actual error. It's just that it's just processing the information. I'm not sure exactly what this means. I think it just says that there's like 15 different segments that were generated. I think that's what it says. But yeah, now we wait for the proof generation to happen.
Okay, so if you see that message though, and then there is not anything after it, then that is an error, right? Because I've tried it twice, and it was getting that message at segment 2, and then it doesn't do anything past that.
So VS Code doesn't update based on, like, you have to navigate away and then again. So you see how like,
well, I was like in the terminal
if you would know if there is additional like something is entered here. Let's see. Yeah, there it is. So it's not an actual error. It's just that it's just processing the information. I'm not sure exactly what this means. I think it just says that there's like 15 different segments that were generated. I think That's what it says. But yeah, now we wait for the proof generation to happen.
Okay, so if you see that message though, and then there is not anything after it, then that is an error, right? Because I've got it, I've tried it twice, and it was getting that message at segment 2, and then it doesn't do anything past that.
So VS Code doesn't update based on, like, you have to navigate away and then again. So you see how, like,
well, I was like in the terminal in the Docker file, and I was tailing it.
Okay, so you're getting a live read for this. Okay.
Yeah, and I think it's still. I'll check it, but I think it still hasn't done that.
I see. But yeah, I guess, like, for this one, I don't think this is an error. I think it's just the information that we've split this into 15 segments. But if you do, if it doesn't process for you, like, I guess it should work. I'm not quite sure on because it's worked for me so far. That's basically what I can say, but I'm not.
What else do we see? Like, what files should we see? Are there files we can look for to see if it actually generated the right thing?
Yes. So this will take a few minutes, or actually potentially a few seconds, but don't want to get too optimistic. Okay, there we go. So it says something successfully wrote proof to common circuit data, verifier only circuit data, and then proof with public inputs. So I believe that is located in, let me just double check over here. Okay. I think for the Golang based program, it is written inside of the, let me double check, the elf path, JSON path. So that's compile guest program that's in here. Yeah, this should be in, I believe it might be in, it's zkMIPS tool now. Yeah, so hold on, ZKM project template. It should output, for the Rust-based program, unfortunately, the Golang program doesn't match what the Rust program is. I think I will let them know for this, but it should output into the contracts verifier and contracts SRC.
Okay.
But then inside here, the network proving will always, no matter what the program would be. Oh wait, here. Why am I doing this? We go into zkM prove, and then inside zkM prove, we can see the SHA-2Go program, and we see that the data would be returned as, yeah, log info where the data is returned. I want to get back to them, because there is a discrepancy in terms of that. So I think for the previous version, it outputted to like ZKM, TMP ZKM, but I don't think that it would output there again. I think they've since updated the Rust version for it. They did all these changes recently, but in this case, if you're running the Rust-based program, Rust-based proof, it would output into the contracts folder, into the verifier. But I think in this case, it would output still to the temp ZKM. And if the ZKM folder isn't created, let me just try this again, maybe. If I were to create, like, yeah, so if I try to create this, and if I try to do this again, like cd host, it might go into here, but we'll see. We'll check it out. For now, I do recommend everyone to use the network proving. This is the most, this is the fastest, and also works in the exact same way for all programs. So
and how do we get access to that? How do we set that up?
So I have written in the Discord to send me your public key that you have access to the private key for. You can generate this potentially through MetaMask. You can generate the any type of essentially address that you have the private key for. So exchange addresses don't work, obviously, but like over here we have the you would enter the private key, and I have I would say like a template file here somewhere over here. I think it might be let me try to go ... and then I would send it to CD example, maybe here. I have one program, maybe ZKM project template is the one. I have a couple. And then maybe we do a cursor. So yeah, right here. Or you can use this private key. But it's I think potentially rate limited based on a specific address. So better to have your own. But you can also use this one for just testing purposes.
Can you post that one, because we can't really see it, just in case, like, because that might be also a good thing if we try to get it working, it doesn't work for us, but that one works, then maybe we know that there's something wrong with our key or something.
Yeah, like I will if you paste your public key, I'll put a check mark, or I'll put like a thumbs up next to it, and that means that that key was added to your file. But
Okay.
I'll anyone that's seeing this recording can probably potentially type this out, but I can also like put this in the chat just in case. But that being said, it might rate limit, so I'll you know what, put this in the chat just for anyone to potentially copy. But yeah, this is a key that works for proof generation essentially. So same thing, seg size, you want to leave it to the maximum. You have the inputs for here. And so we then want to generate the proof. So generating the proof from this, we would just do this. We just do run network, CD into the host program. And then we would do run network proving.sh, and then we would run the file that we're trying to prove, which is SHA-2 and then boom. And there should be a file over here that is created. Oh, this is in a different directory potentially. That's why. Let me just go back a bit. Demo CD zkM. Yeah, that's why you don't see the file, because I'm in this directory right here. So this is actually running the network proving right here. But if I were to do the same over here, I would do CD host program, and then I would do the same command over here. So run network proving.sh SHA-2 go. I want to see, yeah. So we can actually see just over here. I don't want to overload the server. Again, based on the number of requests, we don't want the server to work a bit too hard. Okay, perfect. Generated proof successfully. Proof file and the verifier contract and paths contracts verifier and contracts src. So this is the output that you should get. And the contracts verifier.sol over here is generated from the actual execution of the proof. And then it gets put into this folder as well as the verifier. So the verifier also gets put into here. And if I ran the same program here, I I have the network proving, and the same outcome is that the output files for the network proving, as well as the Rust-based, but I guess the Golang-based program outputted something in the common circuit data.json verifier only. I believe there is a verifier contract directly on that. A folder gets created somewhere. I just don't know where. That's why they standardized it to basically just output the snark proof, or the proof with, snark proof with public inputs. But so that you don't have to worry about the mess of like, where is it located? It should output in the contracts folder. So we have the verifier snark proof with public inputs, but it hasn't yet. This is here by default. But I think we should see like an orange, like once it's done proving, essentially, like generated proof successfully. Oh, contracts verifier. Okay, so it did run successfully. Okay, there it is. Okay, so it just ran successfully, and we see that now it's orange, which implies that it was changed. So over here it's 809. Let's see if I press Control Z, what does it do? I think it doesn't have the history because the file directly changed. Never mind. So but you should get the verifier.sol and the snark proof with public inputs. And so what the verifier.sol does is that you can deploy this on any EVM chain, and it takes in, as part of the parameter, the snark proof with public inputs. So this is essentially what you should get if you ran the proof and it was successfully generated. You would get this proof right here. And let me just see if I can, so you have like these, the big numbers that relate to the mathematical guarantees of the program execution. All right. Any questions before I move on to the potential example on how this can be implemented in a project?
Can we just quickly go back to that library that you have to copy for the host program? Because I was able to, I thought I was the SDK library. I thought I had properly gotten it compiled, but I don't see that file anywhere.
libsnark.dylib.
Yeah, and where did you copy it from? I guess is the question.
It would be under SDK, SRC, local, libsnark.
Okay, let me check that out because I maybe I was looking in the wrong place. SDK. Okay, so under the SDK source local libsnark, I have a bunch of files under there, but I don't have one. Are you copying the whole directory, or are you just copying? Is that a file?
I copied the individual file libsnark.dylib. Okay,
that one I don't see. I have a bunch of stuff.
Yeah, there should have been like compile.sh, contract.go, and then so there should be libsnark.h that was recently generated from that, and then libsnark.dylib. Okay, I have.
Okay, I've got libsnark.h and libsnark.so because I ran it on a Linux machine. Okay, I think that's why, right? Because it created a Linux executable.
Oh, okay.
Is that okay? Yeah, because I was running it in the container, and I have this mounted. So when I started the container, it's got a mount from my Mac into the container, and when I ran it and compiled, then it created all of those files you just said, except instead of libsnark.dylib, I have libsnark.so because it's a Linux executable. Does that make sense?
Yeah, I guess I'm not sure how to convert that into.
So in this case, but then if it's looking for .dy.lib, then I would have to change the program. If I copied the .so file, I'd have to change the program to be looking for so, right?
Yes. I think I only tried it on a MacBook, so I didn't know that there was that discrepancy with the SO, but I'm trying to think. So you're getting the SO file from running.
Yeah, all of those same files, except I have the libsnark.so instead of the .dylib, because I was running it in the container.
I see.
Trying to run everything in the container.
Got it.
Because I don't have Linux.
Okay, so when running this in a Docker container, this would generate an SO file.
Yeah, because the Docker container uses Alpine Linux, and the Linux is the .so. That's the executable on the Linux OS.
So dylib. I'm just thinking like, because that's a library. It's not an executable. I'm thinking like.
Well, I guess the SO, yeah, it's like a library or an executable file, but it's specific to Linux though, because that's what it was run on.
Yeah. Okay. In that case, I'll let the devs know about that. So you're essentially getting an SO file,
yeah,
rather than a dylib. Okay, I will submit the dylib file on actually I'll do that right now on the Discord. Like, I guess right here, the ZKM hackathon. Yeah, I'll just get the right here, just here, and then I won't stage manager. Yeah, so I'll just maybe, hopefully this works. No, it doesn't. Okay. But I'll upload the libsnark.dylib directly to the ZKM hackathon, so that in case that, because it shouldn't happen, but I guess yeah. And then I'll let the developers know. So there's two issues which was noted during this demo session. Was that one is that the Golang based programs would essentially output the what is it, common circuit data verifier proof, and then the Rust based programs would output directly to the contracts folder. And then the second one is that the library, the libsnark library, you don't have the dylib.
Yeah, not if you run it on a Linux machine. No.
Got it. Okay. In that case, thank you. That's very helpful. Okay.
Can I ask another question related to that?
Of course.
So the reason I use the Docker container is because it says that this is all very specific to specific chipsets and OS, and because I have a MacBook, I thought, oh, I'm not going to be able to run this stuff because it says I need to run on Linux. So I thought, oh, there's a Docker file. I did have to make a few changes to the Docker file, but I'll just run it, in a container and just do everything there. But then, mounted the actual instead of starting the container and then cloning it, I actually just mounted my local, so that it's shared. And that's why I ended up with the .so file in there. But so you were saying though that some of the things should be, I think it was the guest program really can only be compiled, like the Rust guest program can only be compiled on Linux, but that the other programs could be compiled on a Mac, or did I misunderstand that?
Yes. So the Golang based program can be compiled on a Mac because the Mac has, or Golang has a MIPS support directly within Golang. So you can compile down to a MIPS binary. Rust, you need that additional package, which is not present on Mac OS. It's present on Linux. So that's the reason why. So Rust-based MIPS programs can only be compiled on Linux, whereas Golang-based MIPS programs can be compiled anywhere.
Okay. So does that mean when you're saying that the Rust-based MIPS programs, are we talking specifically is that only the guest part of it? Because I think you compiled the host program on your Mac. Is that correct? So it was really only the guest program of the Rust that would have to be done in Linux, or am I not saying that right? Because I've run other Rust stuff on my Mac before.
Yeah,
without a problem.
It would only be for the guest program, because that is the program which you are compiling to you are cross compiling that one. So
Okay.
like so if you see this SHA-2 go binary, so the reason why is if I go into like cd guest program, and then if I do SHA-2 go, and then if I try to run this, it says exec format error because it is a MIPS executable. It can't be run on the on a like any device other than like a MIPS based or like sorry the machine needs to be MIPS based. This Mac is an ARM Mac, so I would need an ARM based program. Same thing with like if I were running this on like an Intel, I would need like an x86.
Okay, see, I have an Intel x86, so that's also one of the reasons I was doing it in the container, but then it would still be the same core.
Yeah, I think but for Linux they have well you still can't run the file directly. You can run this within the zkVM because that's what the MIPS binary is, but it's the like you could still compile it. You can cross compile MIPS with a Linux machine, so it doesn't matter what instruction set your machine would use, because cross compile support is best on a Linux. But if you're trying to do this on a Mac or a Windows, then you might run into some issues because it's less supported.
Okay, but the SDK, I could compile that on my Mac too. So if I do compile that on my Mac, I would get that dylib if I compiled that on Mac instead of in the container, correct?
Yeah, that should be. I did it on my Mac, so
okay.
Like, I'm sorry for the works on my machine, but like it's like like you should get the dylib if you run it directly on your Mac. So
okay. So if I understand correctly, then the only thing that we have to compile on Linux is a Rust guest program.
Yes, correct.
And everything else we should be able to compile on like Mac or some other OS. Okay. So then we can use the container really just if we're writing our guest program in Rust, as long as we have the container and we mount it to, a directory on the Mac, then you should be able to compile it in the Linux, and then you have the libraries available.
Everything else, can be run directly on that device. You're absolutely yes.
Okay, so once the Rust guest program is compiled, then I can run it on the Mac, right? Or no?
Once like let's say we do the Rust executable, so we do the like mem alloc vec, we compile this to Rust. We can then put this into this folder, but you would run this in the Docker container. You would generate, it would already generate, and then you would run it directly on your Mac, and then that would work. Yeah.
Okay, so we can do. Okay, so if we compile the Rust guest program in the Linux container, then we can do all the proving and everything on the Mac.
Correct. Yes.
Okay. Okay. Now I think I understand.
Yeah, because the ZKM prove is that runs directly on your machine. So, but the guest program runs in the VM.
Okay.
So, yeah, thank you for those clarifying questions. And anything else before I move on to like just how this can be used in like smart contracts?
Yeah, I just had one question. So the host program is in Rust itself, right? Independent of what the guest program is written in? Correct.
Yes.
Okay, and it's compiled. It is the prover basically, right? It's trying to prove the guest program.
Yes, it is the prover. Yeah.
Okay. And my other question is more related to a practical use case, but I guess we'll get to that.
Yeah. Actually, just right now, I can just very briefly. Where's the? There it is. Okay. So I have another repo that I I forked the scaffold ETH repository, and then specifically over here, see if I can get this to work in my cd dot and then git clone. So I have this SE2 challenges repo. So if I do cd SE2 challenges, now I branch. Oh, git branch. Yeah. So I think check. I believe there is challenge 0, simple NFT challenge. Challenge 0, simple NFT. Hopefully that's one word. Nope, that's not. There it is. Okay, so the way that how this repository is structured is that every single branch corresponds to a different program. And if I do like, what is it? Cursor dot. So I get a development environment and right. If I go into cd packages next.js, or maybe directly from here, let me just count chain fork deployed, generate, compile. Yeah, I think I have to do it directly within the Next.js. Yeah, Next.js probably has. Yeah, okay. So sorry, cd packages, and then Next.js, and then I have maybe npm yarn, and then yarn would install the so it'd go through the packages, and it would install all of the required things in order to run this. I'm assuming everyone here might have heard of, just briefly for background context, speed run Ethereum. So this is a very good resource for just learning about smart contract development. And then as part of this quest, you would essentially create a simple NFT. Now, once this is finished, I would be able to run this in the console. Let me just, okay, yarn start, or I think yarn run dev, sorry. Dev. Yeah. And then now I have the local host. And there should be, sorry about that. There should be, there you go. Now, I don't think I created my, if I do cd dot yarn chain, I believe. And then this should create a development environment specific to this. So it says wrong network. Okay, switch to hard hat. But hard hat isn't running until I click yarn chain. Oh, couldn't find package. Oh, yarn, maybe. Sorry. I switched a bit too far. SC2 challenges yarn. I need to install it. Or actually, my computer's fans are okay. So I am running a hard hat instance. Now I have 0.00 ETH. I have the network running. If I click this, I have I can transfer assets to myself. So now I have 0.1 ETH. Okay. So we have the environment set up. That was the important part. But basically what this does, if you click a button, mint NFT, you would be able to, okay, calling an account which is not a contract. So this is important. We need to deploy the contracts first. So what it's doing, if I were to create a new terminal, it would be yarn deploy, I think it is. But it is inside here.
I think you have to do that from the hard hat directly, maybe.
Yeah, so over here, like in the package JSON, they have like a couple scripts over here. So there's account, chain, deploy right there. Yarn workspace, SC2.
Yeah, okay.
So then I deployed your collectible. Now, if I click mint, I should ideally, or maybe refresh first. If I click mint, it should mint an NFT. And I have this dialog, sign, confirm. Oh, because I minted it on a separate network, I have to reset I have to reset. Oh, how do I do this? More, maybe? Advanced? Clear pending? Yeah, there it is. Also reset my local nonce because I regenerated the network, which kept track of my nonce locally. But since I completely wiped the blockchain, that's, in hard hat, you need to also clear your nonce for this network. So after I cleared my nonce, I click mint NFT. I would then get this dialog, and then sign, confirm, and I should get an NFT right here. So this is how it works by default, but there's one key important part here. Over here, we have the contracts folder, and we have, okay, one is the deployed contracts, but this is generated from, where are you? This is generated from hard hat contracts. There it is. So as you can see, there's two contracts here. There's verifier.sol and there's your collectible.sol. Actually, I'll go one down. So your collectible, originally, this wasn't present here. So I added like a few minor things. Actually, it's better to take a look at what I added here as part of my changes. So if I take a look at the challenge 0, I can see the changes that I made on GitHub. So over here, I imported verifier.sol as part of your collectible. I changed the constructor. So I added the verifier as a address that your collectible.sol is pointing to. And then essentially upon creation of your collectible, I instantiate a new verifier contract. So what this means is that when I create my NFT, or when I create my NFT contract, I would attach a verifier to it. I would create a new verifier. And then I would store it over here. Now, from here, what I essentially did is I changed the mint item to a mint item with proof. Or sorry, mint item, and I changed it to mint item with proof. I also included a modifier, which is essentially just like a require. Like it requires a certain action to be true in order to execute. So this requires that the proof that I am submitting matches the is a valid proof, essentially. So that's all it's doing. It's not taking any of the inputs. It's not taking it's not comparing anything. It's just saying, hey, do you have a valid proof? I believe that is there likely is a way to compare the actual values but I was told by the development team that a snark removes a lot of information. So if you had a Stark proof, which we generate a Stark proof, but the final result is a Stark proof. With a Stark proof, you can take in additional contextual information. With a snark, I believe you can't directly compare the inputs unless
I think you can with a snark, because I did something with CIRCOM and I wanted to check the public input that was in the input field, and it was available. The public input and the public output was available, but
yeah.
maybe that's different here than what gets generated by Snark.js.
So over here, like at least with the snark proof with public input, it's essentially like a big number. So you wouldn't get the actual value. I believe you could potentially pass the value as well to the contract and then compare it based on the witness that so you would essentially say, hey, was this an input that you provided to the prover, and then for this specific program, and I'll actually demo like that for this specific program. But what essentially what this is essentially doing is I am checking the validity of the proof, and if this is a valid proof that is associated with a specific program, because the what was it, the verifier.sol is only created to accept the programs that are generated for a specific program. Sorry, that sounds confusing. I'll show what that means.
It's specific to a specific proof, right? You can't generate one and then use it for another one, right?
So you can generate multiple proofs with different inputs, but the actual program itself cannot change. So you can like in this example that we did before with this, notice how I changed the inputs, so args, and then from this input change, like the program remained the same. It's still SHA-2Go. It's just that the arguments changed. But yeah. I don't want to redeploy my verifier every single time my arguments change, because that's the point is that people that are running your specific program, they need to generate a proof on your specific program, not on like a valid proof for a different program. So to give this context over here, so now that we know like the changes that I made to the actual repo, what I'm doing is I'm passing in as part of the program itself. I believe it would be over here. Let me go into the, I believe it's proof. Yeah, proof here. Okay, so this is the test suite. So I believe there is a different place where I go in and put it in. Okay, page.tsx, snark proof. Snark proof with public inputs. And I'm essentially taking snark proof with public inputs, which is a proof that I generated for a different program. And over here is I basically take this snark proof and I put it in, and I break it down into I break it down into the receipts, and then I take the individual components of it, and then as part of minting, I would put this information as part of the mint item. So we saw that mint item in here contained a requirement with proof. So I have the address to the IPFS URI, the proof, the input, and the proof commitment. This would then check with the verifier contract. It would say, so it would verify the transaction, and if it's not valid, of course, it would throw an error. So let's try to replace the snark proof with public inputs with a different, with the different one which we just generated. So we just generated this one, and we see that 47395, and if we go over here, this is 70488, right? So they're two different proofs. I wanna select all, copy, and then I will replace, select all, paste, save, and it should format it correctly, hopefully. Yeah. So over here, you notice that the VS Code detects that there's changes to these values. So if I try to run, I think I need to redeploy or rerun the actual interface potentially. I don't think it automatically refreshes. But I go into here, and when it's done building, I go to my NFTs. So I minted this previous NFT. If I click mint NFT, it shouldn't mint. So that's the point. So let's click. Okay. Potentially the program. So here's what I see. Potentially the program was maybe the same, just different inputs. Okay, so I guess it did mint. Let me see. I might have used the Golang program with different inputs, but in implementation, if I have a different proof corresponding to a different program, I shouldn't be able to mint. So likely this was this verifier contract was generated potentially as like the same was generated with the same program. But let me just double check that.
Just wanted to quickly ask something.
Mm-hmm.
Yeah, is this still using the SHA-2 proof? I mean, like, what's the proof?
Likely, it is still using the SHA-2 Go program.
So it's just that you know a particular word for which the hash, the public input.
Exactly. It's like the particular word for a specific hash.
And is the hash like somewhere related to the contract address or something? Like
the hash is any hash. So as part of this, the proof that we've generated, so it can be any hash for any value.
Okay, but wouldn't that input come from another party? Like if you know the hash to that particular word, and you're passing the hash along with the proof, that's like you already know, you're not comparing it with like a third party input.
So in this case, you have generated a valid proof. So what the proof is showing is that you knew the value of a corresponding hash, and as a result, you would be able to mint an NFT.
Yeah, but
So it's like a secret password or something.
Yeah, exactly. Like you would generate this off chain, or like in this case, like you ran this before, you generated the proof, and the user would then input the proof as part of this. So essentially they would input the like you as part of the proof itself. You cannot derive the value from this. Like you can maybe, I might have to get back, but the idea is that you have generated a valid proof for the hash checker program, and as a result, what this proves is that you knew a value of a corresponding hash, and then you're essentially delivering a proof that you knew a value of a corresponding hash that allows you to mint an NFT.
And with the SHA-2, I think that the input is private then, so that you can't see that. So I have to prove that I know the secret password that someone gave to me, and then that's a private input, I assume, so that it doesn't get revealed.
Yes. Now, I believe all the inputs to the program, so if we take a look over here, all the inputs were actually public inputs, or at least the sorry, that was the Rust. This is the Go. So
Okay.
yeah, so there was no private inputs to this. So it was just the public inputs. So I believe the public inputs is what is the witness over here. So we have the public witness. So these are basically like public inputs provided. Now I think I have to
What is
clarify
the secret word private? Like, let's say I have to prove I know the secret word. Which part of that is keeping that private so that other people can't see it? So that, Bosco doesn't come in.
So in this case, you would put this into the private input.
Okay.
And then from the private input, you would generate a proof that reads from this private input. I believe there's another method to read from private. I should clarify that. All of these questions, so I'm keeping note in my head to make sure that I give you the best possible answer. But you would essentially, for like a correct program, in this case, like we don't focus entirely on privacy in terms of like ZKM. We mainly focus on verifiable computation. But this example of like the hash check is just like the easiest one to go over. But in this case, you would if you were implementing this correctly, you would put the value of the hash into this private input stream, and you would run this locally. Like, because if you send this information to the prover now knows that information that you're sending to them. So in this way, if you generate the proof locally, you would then have a proof that you know the value of a specific hash. And then in that way, you can send it to the contract, and then because you sent it to the contract, that would be like it would be you would essentially prove that within there. Let me try to go over so if you were implementing this yourself, what you would need to do, like if you were trying to add the checker essentially here, you would need to replace the verifier.sol with your specific verifier.sol. So
is that recommended that like we modify the verifier.sol that's generated? Probably not, huh?
So if you modify it, it would likely, all proofs that are sent to it would be invalid. So the point is like the verifier.sol has specific constraints set, so that like if your program did something that was unexpected, and in this case it would be like you were trying to manipulate certain computation outside of the bounds set by the program. So because how I imagine like a zkVM is just one big circuit. So if an execution did something outside the circuit, outside the bounds, that would be invalid. So it wouldn't accept it. In that case, if you were taking if you were modifying the verifier.sol directly, so let's say you change like 3.3 to like 4.36, like that would invalidate all programs, and so it's essentially useless at that point.
Okay.
So you would have to use exactly that which was generated from the program. So let me just copy this. And then if I were to paste in over here, yeah. So this looks like a verifier user data. That could be, I think this is a new, oh, okay. Sorry. Okay. Remember how I said that I can't compare the values of the proof. So I think they just added a method within that allows you to do this. So cool. Awesome. Okay. So the devs are working. But you see, they haven't added documentation for this yet. So as soon as I have it, I will provide it. But you can use this method as part of the verifier.sol to also, in addition to, what we're doing with this proof is that we guarantee that the program was correctly executed. Now you can also say that the program was correctly executed with this input data.
Okay.
So hopefully that makes sense. But yeah, I think so. All the pairing codes changed over here. I want to. There is like a test suite in here, so yarn test maybe. And all right. Okay. So actually, one thing, live demo, I think on the website it doesn't work, but on the test suite it does. So notice how the value is out of bounds, right? I had some initial, so I had the proof in the test suite right here in the challenge 0. So here's my snark proof. So this is 18511. So notice how I just changed the verifier contract. It compiled the verifier contract. And now it says that the verifier essentially experienced an error. So this means that the proof that I provided to the verifier is invalid because it was likely not generated for the program that I was executing. So let me just see if I can. So if I revert this, if I revert the change back to the previous version, and I do yarn test, it passes. So in here, we know that the proof that is provided within the test, so this proof right here, is a valid proof because it is executed within the test suite right here. It is where is it? Yeah. So basically, it mints. It was able to successfully mint an item given the values of the proof. Now, what I did is I updated the verifier contract. Oh, actually, I'll give like another example. If I remove one value inside of the snark proof, change it to 2 or something, then, and if I yarn test it again, I'm expecting that it is invalid. So over here I have the value out of bounds, right? Because I replaced one number. If I change it back to 1, it runs correctly. I believe we do have a test suite directly in this right here. So we have like a test right here. So we're able to run this over there, but so it passes. Now, if I try to input that proof, remember how I generated a proof? I would copy this proof, and let's say I paste it over here. So I am copying a proof to the verifier contract that was not set. So if I to the verifier contract in which the program was not generated in. So if I do yarn test, it shouldn't. I'm expecting that it shouldn't work because it's generated for a different program. So let's see. It should. I don't know why it's taking so long. Okay, there we go. Okay, so it didn't execute, value out of bounds. But then if I put in my verifier.sol that I just generated from our previous example, and I put it over here, paste, save, and then I tried to yarn test, it should accept it as a valid proof. So compile to Solidity contracts. Value out of bounds. Uh-oh.
It may not be redeploying or something. That could be.
Reverted with string no. Yeah, it did deploy.
Oh yeah, because I guess hard hat should deploy every time.
Yeah. Interesting. So yeah, let me. It should. It literally just, you saw it generate right in front of my eyes, but
yeah.
But let me just copy this. Make sure that I copied the value. Let's try again. All right, and then this here, paste, save. Okay, and now, hopefully, crossing fingers. No. Value out of bounds, invalid argument. Did I adjust a value in here? I don't think so. Interesting. Was this for a different? No. Yeah, it should work because I have the Stark proof and I have the verifier. That is a curious case. Maybe when they added this, something happened with it. Maybe, but it should still work. So we generated the proof. We have the verifier contract.
So it should work because you're just putting different inputs in? Is that what you're testing?
What I'm testing is that now I have the proof that I generated from this process. So we generated the program over here, or sorry, within the Go network, and then generated proof successfully. Contracts verifier, contracts SRC. So we have both the verifier.sol as well as the Stark proof with public inputs. And from here, I am essentially putting the verifier.sol over here. So I've essentially copied the file. I pasted it in here. And then from here, I also have replaced the challenge, have replaced the snark proof in the challenge to this one that was just recently to 4739. So this proof, actually, we'll test it directly on the we'll test it directly.
Something's going on there.
Oh no, the proof's not working. Someone called the cops. So
that sounds like the fire department. It sounds like your house is burning down.
Oh. Yeah. Let me just go into the ZKM project template over here. So there is a test suite. Yeah, over here. So this is Forge test, right? ZKM project templates contracts. So we'll try to do that over here. Let's see if that works. So cd ... guest program, I believe here. Oh, because I didn't go into the contracts folder. CD contracts. So Forge would then test. Interesting. Yeah, I guess the change that the developers made, I guess with this version at least, the one that's generated from the remote network, looks like that didn't pass. So curious case of devs do something. Okay, that's a bit of a problem. I'll reach out to them and I'll say that it doesn't work. But yeah, because the proof that is generated from this doesn't match. I have a feeling it has something to do with this addition of verify user data. I have a strong hunch because they recently added this, but I think that they haven't. That change might have affected the. That change might have affected the actual proof generation. Difficult case, but allegedly, everything that was generated so far, at least like by default, worked in the previous versions. But I guess like this newly updated version might be a bit too unstable. Okay. Yeah, sorry about that, guys.
If they make some changes, can you maybe let us know that? Because I've already forked and then cloned this. So we've already have our own little repo that's basically just a copy of this, but it's not, since I cloned the fork, it's no longer like attached. So I would need to go get any changes.
So I think that's another thing is that the network proving is potentially not running the exact version of the local proving, or like whatever the program is. So the value that you're getting from the network proving might not be the value that is what you're expecting. So in this case, like if I were to do the Rust program, if you were to do the local proving, I believe in the current version it should work, but for Rust-based programs, actually I'll do this really fast, just very, very briefly. I want to prove at least like one Rust-based program. So in this case, just so that we can, I want to have like you generated a successful proof, at least for this case. So inside the Docker container, I guess we had actually wait, Docker run IT. So over here, do home. Okay. Clone the repo. But yeah, I'll rather than use everyone's time, but the local proving should work. You just need a MIPS executable to generate from this. But I guess
I was having trouble I could not get the local proving to work for the SHA-2 Rust.
Okay.
I didn't try it for the Go, but I couldn't get it running for Rust. The SHA-2 Rust.
You know, I think just so that if I experience the same issue and it's recorded, I can send this video to the developers as well. And then, so we go over here. We should be able to, from here, at least, git clone. Let's run through the proving for this. Yeah, very, very peculiar. Yeah, git clone here. So cd into this guy. So now that we have our local environment, I want to go here. Now we can go into the Rust MIPS tool. So cd into ZKM project template, Rust MIPS tool. This will pull this within the Docker container, but I think it won't it won't pass likely because I need to create the cargo file. So
yeah, I had to add that. I had to
Yeah.
add that to the Docker file, and I also had to add another library to the apt-get in the Docker file to even get like this part running.
Okay. Like, I mean, it should run. Wait, you needed to add it in another app?
Yeah, I think it was maybe for doing that because I was trying to build the host. So to build the guest program, I had to add the thing to touch the .cargo file because it wasn't in there. And then I think to get the host program working in the Docker file, I had to add something else, another library, which was called like protobuf-compiler.
Oh, interesting. I guess we'll just compile the program here, and then, like, as you said, we just need to compile the program, and then we can run everything on the MacBook.
Yeah,
So
I was trying to do everything in the Docker container, so maybe that's the difference.
So we can go to cd sha2 rust, and then run this command right here, cargo build. All right, so it should be good. I would have to access this from the inside the VS Code Docker container. That's like the easiest way, I think, for copying files. So I can go into this home, ZKM project templates, guest program, SHA-2 Rust, and then it should output the as soon as it's done generating the file. Yeah, but that's very, very peculiar. The update that they've released doesn't generate valid proofs, at least for the remote proving. So that's a good point. Glad that we detected it together. Okay, so it released a file here. There it is, target, release, and I believe it is not the build. Oh wait, no, sorry, MIPS, unknown Linux, I believe, and then right there, SHA-2 Rust. So I would download this into the, let's see.
I think it's the whole directory though, isn't it, that it generates, or no?
Okay. There it is, SHA-2 Rust.
So that's all you need then, okay.
That should be all you need. And then I'll put it into the SHA-2 Rust folder. I guess, potentially. It might try to look for it somewhere else, potentially, but let's see. Let's see. We would want to exit from here, or maybe, I don't know how to copy entire directories though, or like.
Yeah, I had mine mounted, so I just had it so whenever it generated something, it generated it also on the shared drive on my Mac, so I didn't have to copy it.
Yeah, I'm not sure how to, if I were to take this target, how to copy the entire file into the host. There's like a docker cp command. I have to look it up. It's like tar.
Yeah, well, if you start up the Docker thing in a different way, then you have it. But maybe if you can like do it, and then you can send it to us like in. Let me find the command that I used. But
I believe just the executable. But then I saw that there was like a file that was like a link essentially. So potentially, like there was a like release. Release, and then there was like SHA-2 Rust, but then SHA-2 Rust D. So I'm like, I would say, okay, let's copy everything.
I used this command to start up the Docker, and it had my so I mounted like the directory I was in, which was the ZK project template, to the /zkM in the Docker container, and then it was everything I generated from the Docker container was, also on my Mac because it was a shared mount.
Okay.
And I ran that, yeah, from the main project directory.
Oh, it's still, or maybe you have to rebuild it.
I think if you exit out of the Docker container, it should use the same image, but you just need to run it at the container. You have to kill the container and then run it, start it up in a different way.
Okay, I'm using this command, but let's see if potentially it will run with just the file that I put into the.
Okay.
But let me just double check the local proving if it's going to guest program. Yeah, program SHA-2 Rust. Yeah. Okay. So sudo cd host program, and then run local proving.sh SHA-2 Rust. It's trying to compile it. This won't work.
Now for this one, is that copying that lib note required also? And maybe you've already done it from the previous time, so maybe it's not.
Mm-hmm. Yeah, it won't compile, so it would need to go into export.
Hi Pavel, sorry to interrupt.
Mm-hmm.
Yeah, so we are almost nearing 2 hours. Would you like to take it in a next session, maybe in a couple of days, or would you?
Yeah. We'll probably I'll probably circle back just to get the development process a little bit clearer, but ideally.
Can you just share also that other repo, the SE-2 challenges? Yeah. Is that a public repo that we can?
Of course, yeah. Sorry about the technical aspects of demos. It's doing it live is always always a struggle. But yeah, I guess I'm glad that we have like Heather, we have you, and then like everyone else is here. It's if you do get stuck, if you do have questions, if you're like, wait, this doesn't make sense, you're probably on a good hunch. So
okay, good to know, because I would have been like trying to figure out what I was doing wrong the whole time.
Yeah, like this stuff is complicated, but hopefully, I clarified a little bit how to use the code base. Sometimes a thing might not work as expected, and if it doesn't work as expected, that's 100% a problem. I'm gonna let I have some feedback for the developers. So, but thank you all for coming here and contributing with this. Hopefully,
I find it very helpful, at least, to understand. Like, at least now I understand that which part I need to do in the Docker container and which part I don't, and that kind of thing.
Yeah, exactly. And then if at some point, like at any point, you run into any issues, feel free. Like, the Discord is always great to like come in and debug. But yeah, we want to make sure that everything is in order and sorted. And yeah. Thank you so much for attending the session, and then I guess
Thank you so much.
See.
Really appreciate all your 2 hours, and I think we'll share the recording as soon as possible, mostly by tomorrow morning. And I would recommend everyone to go through the recording, follow the steps, and if you're stuck somewhere, feel free to post your questions or errors in Discord, and we have Pavel to help us. Thank you so much for appreciating.
One more for the question in the chat. I think Bosco asked, and then he needed to leave. Can I use generic Rust libraries or Go libraries in my guest program? Yes, although some libraries might not be supported. It's like a trial and error process. That's why you would set the execute only to true to test out those things within the environment. So I tried for the hackathon project to use like a pretty extensive Rust program in there. I wasn't able to get it to compile, but it essentially, for the reason that you needed different Rust versions, you needed to make sure that it's all, like the bigger the program, and then the way that like the programs also work, you need to make sure that it's not no STD for the Rust based. It does take a bit of porting if you're using existing programs. So I would recommend writing it as simple as possible with no external dependencies. But then if you're looking to do that, you might run into like a few issues for like the integration. And then I guess one of the crypto libs for elliptic curve public private key operation signature generation. Yeah. So for example, the SHA-2 Rust or like the SHA-2, I was able to get that to work directly. So that like in terms of the crypto libraries, I think they should work out of the box. But for other programs that might have other external dependencies, it might not. It's like a trial and error based. But I had to write sometimes like your own hashing algorithm potentially, but something that copy paste couldn't could help with. But I'll leave it at that. Thank you so much for attending. Sorry I went into a bit too much of the error side, but feel free, ask any questions. Always happy to answer.
Okay, we will probably get posts from us in Discord.
Awesome. All right, I'll see you guys in the chats.
Okay, thanks.
Thank you, Pavel. Thanks everyone for joining.
Okay.
Bye-bye.